Alright guys, hope you all are doing okay. So I wanted to take some time to make a video over last week's FRQ. I'm going to go over it hopefully relatively quickly so I don't make this video too long. Sorry about my copy. My copy is terrible, but I think you have the problem in front of you. So let's go ahead and get into it, okay? So the problem says the following. You have a function and you're given f prime, so it's going to be very important. So it says the function f is twice differentiable. You are told that f of 3 is 7, so that's going to be important. I'm going to go ahead and write that over here because you guys can't see it. F of 3 is 7. The graph of f prime is the derivative of f. Okay, that makes sense. It's shown above. And it says for 1 to 6, so from 1 to 6, f prime of x is linear segment. So I'm not sure what that means right now, but I'm just going to kind of keep that in my head to see what happens. And then you are told h, which is not shown, is defined by 2x minus 5. So now I know that h of x is 2x minus 5. Okay, so let's see what they want us to do. And it looks like a pretty straightforward FRQ, to be honest. But let's see. Now you are told that g of x is equal to, let's see. We're told that g of x, so you guys can see it, is equal to f of x squared minus 1 times h of 2x. Okay, now I already know what h is. So let's see, they want g prime of 2. So I think I'm just going to go ahead and plug that in. So that means that I have times 2 times 2x minus 5, right? So that is all, that's h of 2x, right? So all I did was plug in 2x into that. And they want us to figure out what g prime of 2 is. So I'm just going to clean up this a little bit. So that gives me f of x squared minus 1. And then if I multiply this, that would be 4x minus 5. Pretty straightforward. It's not a very difficult problem. So first we got to find g prime. So g prime of x. So this looks like we have a chain rule and a product rule here within. So I'm going to take the derivative of this first, which is going to be a chain rule. So that's going to give us derivative of the outside, which would be f prime of x squared plus 1 times the derivative of the inside, which is 2x, times 4x minus 5. Plus, we're going to leave the first one alone. So f of x squared minus 1 times the derivative of the second, which in this case is just going to be 4. So there's our derivative. So now we just want to know what g prime of 2 is. So g prime of 2. Since you're going to be working this on your own, I'm assuming you're going to have a lot more room than what I have. So I'm probably just going to have to grab some paper here in just a minute. But okay, so what we're going to do is just plug in 2. So it's going to give us f prime of, so 2 squared. I'm sorry, it's not plus, it's minus 1. My fault. You got to be very careful not make those mistakes on the AP exam. Okay, so if I plug in 1, 2 squared is 4, minus 1 is 3, so that gives us f prime of 3. And then 2 times 2 is 4, so times 4. And then if I'm plugging in 2 in here, 4 times 2 is 8, minus 5 is 3. Okay, plus, let's see, we plug in right here 2, that's 3, that gives us f of 3. And then times 4. So that means g prime of 2, we need to figure out a few things. Okay, 4 times 3 is just 12, right? Now f prime of 3. Well, f prime, that's the graph here. So all I have to do is just really look at the graph here. So what's f prime of 3? F prime of 3 is literally 2. So that's going to give us 24. And on this side, f of 3, well, f of 3, that was given to us. F of 3 is 7. So 7 times 4. And 7 times 4 is 28. Which in this case gives us 52. And I think that's what they will be looking for there. You don't have to go any further than that. Okay. Let's see, what else do they want? Okay, so part B a little hard to read. So I'm just going to kind of flip back and forth between the paper and just some fresh paper so you guys can see. Okay. All right, so part B, you are given the integral between 2 to 4 of f prime of h of x dx is equal to 22 over 3, and you are told to find f of 1, f of negative 1. Okay, so here really when I look at this problem, I'm really thinking, I mean, this is a really straightforward. There's not a lot of thinking. You really know what to do. It's like you got to integrate. So you got to think about which integration technique works the best. Well, one of the advantages you have is you know what h of x is. So at that point, I mean, I really, when I see something like this, all I can think about is u sub. So let's kind of rewrite the problem with h of x in it. So 2 to 4 f prime. Now h of x, if we go back to the paper, h of x was given to us is 2x minus 5. So 2x minus 5 dx is equal to 22 over 3. Now I know this seems far-fetched as to where is this coming from, but I think if you bear with me, I think I'll guide you in the right direction. Okay, so it looks like a u sub to me. We're gonna let u be 2x minus 5, which means that du would be 2 dx. Now I don't have a 2, but I can put a 2 there, which means I can throw a 1/2 out there. So then this becomes very simple. This becomes 1/2 integral 2 dx just becomes du. I still have this 22 over 3, and then instead of f prime of 2x minus 5, it's just f prime of u. Now this is where I think this is going to come into play. Instead of keeping the 2 and the 4, let's remember I talked about this. You can change those two in terms of the new variable that you're using, which in this case is u. So if I plug in 2 into this equation, 2 times 2 is 4, 4 minus 5 is negative 1, and there's that negative 1 they're looking for. 4 times 2 is 8, 8 minus 5 is 3. So now I don't have to go away from u, all I have to do is integrate in terms of u. So what is the integral of f prime of u? Well, that's really just going to be f of u. And that's going to be evaluated from negative 1 to 3, and that has to be equal to 22 over 3. So we're going to solve this really quickly. I'm going to multiply this by 2, which is going to give us 44 over 3. That's going to give us f of 3 minus f of negative 1. Now, f of 3, once again, showed up for us. F of 3 is 7, so that's going to give us 7 minus f of negative 1 is equal to 44 over 3. I'm going to subtract the 7, so it's going to give us negative f of negative 1. That'll give us minus, so 7 times 3, that's what, 21 over 3. So that's going to give us 44 minus 21, that's going to give us 23 over 3. Divide by the negative, that means that f of negative 1 would be negative 23 over 3. Okay, pretty straightforward. This has been a relatively simple FRQ so far. Let's see what part C has in store for us. Part C says evaluate. So you are given the integral between, oh god, it's hard to read. I think it's 1 to 5. F double prime of x, h of x, dx. Okay. The moment I saw this, I could think right away. All I can think of is first is u sub, but I don't see how one is the derivative of the other one, so u sub is not going to work. So the next thing I can think of is integration by parts. Okay, so I'm going to do integration by parts for this and see what happens. Okay, I'm going to let u equal h of x, and I'm going to let dv equal f double prime of x. The reason for that being is because I can take the derivative of this very simple, and I can integrate that very simple as well. So if I take the derivative of h of x, that would just be h prime of x, and v would be just, instead of f double prime, now it's just f prime. Cool? So remember, so now we've got the integral from 1 to 5 of f double prime x, h of x, dx is equal u times v, which in this case is h of x, times f prime of x, minus v du, which in this case is going to be the integral from 1 to 5 of f prime of x times h prime of x dx. Cool? So now this looks like I have a whole bunch of things here, but don't forget, you know what h of x is. Go back to the problem. H of x is 2x minus 5, which then at this point I can then find h prime of x. So h prime of x would be 2, which helps us out a lot. So let's kind of make those substitutions in. So we know that h of x right here, that is going to be 2x minus 5 times f prime of x minus h prime of x was, we just found out that it's 2, so I can pull out that, so that's going to give us 2 integral of 1 over 5 f prime of x dx. which then simplifies things quite a lot. So we got 2x minus 5, f prime of x minus 2. The integral of f prime of x is simply going to be f of x. And then all of this will be evaluated from 1 to 5. Okay? So now we've got this going on. We're going to plug in 5, and then we're going to plug in 1 and subtract them. Okay, so if I plug in 1, 5 times 2 is 10, minus 5 is 5. And then f prime of 5. Don't forget your graph that you were given is f of prime. So f prime of 5, so I'm going to 5, f prime of 5 is negative 2. So that's going to give me a negative 2. Minus 2 times f of 5. Okay, so I was given f of 3. I don't know what f of 5 is yet, so let's put a pin on that and let's see what happens here in just a second. Cool? So all of that is going to be minus, and I'm going to plug in 1. So 2 times 1 is 2, minus 5 is going to be a negative 3. F prime of 1, once again I'm going to go to the graph, f prime of 1 looks like to be a 6, so that's 6. Minus 2, f of 1, which once again was not given to me. Okay, so we got a problem. I don't see anywhere in the problem where I have f. So what can I do about that? I need to know what f of 1 is, and I need to know what f of 5 is. And here is where this is kind of a tricky question, but here is that highlighted piece of information. Remember how it's very, very tricky. You gotta be really paying attention. It says from 1 to 6, you have a line segment. So on this graph, that means that from here to here, you have a line segment, which means that if you have a line, you should be able to come up with the equation. So right now, this right here is the 0.16, and this right here is a 0.5 negative 2, which means that if I find the slope of that, change in y, so negative 2 minus 6 is negative 8. And then 5 minus 1 is 4, which is negative 2. Which means I can come up with an equation. I can say y minus 6 is equal to negative 2x minus 1, which if I clean it up, that is like saying y equals negative 2x plus 2 plus 8. Here's what that means then. That means that the graph from here to here, that means that f prime of x is equal to negative 2x plus 8. So I'm going to be able to then integrate that, which means that f of x is just going to be negative 2, which we already know that. You know, it's going to be the slope there. Okay, so how can I use that then to help me? Well, I'm good to go then at that point. I know what f is now. I know that f is, f prime from here to here is that. So if I integrate that, alright, actually that doesn't make sense, guys. Sorry, now that I think about it, like, I don't know, I was thinking of the derivative. We're integrating, my apologies. So here we are, we seem to be stuck. So how do we figure out what f is, what f of 5 is, what f of 1 is? Well, I'm kind of glad that I got stuck so that I can get you guys thinking on the spot, right? So like right now I'm looking at it, I'm taking longer because I'm having to explain it myself, but I'm looking at it, I'm at 14 minutes currently, right? So I have about 10 minutes left for the first problem, and we are in part C. So I kind of want to speed up a little bit. So let's kind of go back and analyze. Here's where I'm at. I'm going to go ahead and erase this part because after this is where I get stuck. So let's go back to this part right here. It's very important. Don't forget your fundamental theorem of calculus. You have to integrate f prime of x from 1 to 5. Which another way to look at this is that this is the area between 1 and 5 underneath the curve of f prime of x. Don't forget, you have this graph. This is f prime, which means you want the area between 1 and 5. So I kind of already highlighted that. And the fact that it's linear, rather than trying to do all of this algebra that I was trying to do over here, is I'm going to save myself a lot of time and say, you know what? I can just find the area of these triangles. Cool. So real quickly, so we know that from here to here is 6. We know that from here that's 1, 2, 3. So 6 times 3 is 18. So that would be a 9 because it's a triangle. Now we know from here to here is 1, and it looks like from here to here is 2. So 1 times 2 is 2, so it's going to be a -1 because it's underneath the x-axis. Cool? So we're going to use those values to help us out. Okay? So what it looks like is 9 minus 1 is 8. So what it looks like is that the integral between 1 and 5 of f prime of x is equal to 8. So let me go ahead and flip the page. So let's see where we're at. So we were at 2x minus 5 f prime of x. Now I'm going to have to evaluate that from 1 to 5 because I haven't done so, minus 2, and again we just figured out that was 8. Cool? So here we go, we're going to plug in 5. 5 times 2 is 10, minus 5 is 5. F prime of 5 earlier, we had solved that. F prime of 5 we said was -2. Minus, if I plug in 1, 2 times 1 is 2, minus 5 is -3. And then f prime of 1 earlier we said was 6. Yes, so it's 6. And then it looks like -16. So it looks like, okay, now we're just going to clean this up. 5 times 2 is -10. And then we got minus 6 times 3, which is -18, minus 16. So it's going to give us -10, -26, plus 18, which is going to give us -8. And that should be what we're looking for. Cool. Sorry about the hiccup, but I think it's good for you guys to also see me make a mistake, or just so you guys can explore, right? This is the first time me seeing them as well as you are, so take your time, read the problem, make sure that you analyze the situation. All right, let's get moving so we don't take up all your time. Okay, part D. Another evaluate. So this time we want to evaluate the integral from 1 to 2 of 6x over f prime of x h of x dx. All right, so I'm looking at this. We got some, there's no way they're going to put another integration by parts in the same problem. This doesn't look like a simple natural log. So the only technique that I can think of that's coming to my mind right away, it looks ugly, but I'm going to have to try it and see where it takes us. This looks like this is going to be a partial fraction decomposition. Now what I'm going to do is I'm actually going to rewrite this a little bit because we know what h of x is. So f prime of x, h prime of x was 2x minus 5. Now, I have a feeling this is going to break up. So what I do know is then I'm going to try to break this up. Now, f prime of x between 1 and 2. Now, this is, again, this is coming back to. So I just thought about this. It's a line. So it's perfect. So remember, if it's a line, that's going to help us with the algebra. We know that f prime of x is a line. So that means that the top number has to be a variable. So it's just going to be a plus. Oh, my apologies. Sorry. B over 2x minus 5, and that should be equal to this fraction that was given to us originally. Okay, so remember partial fraction decomposition, so I'm going to do a times 2x minus 5 plus b times f prime of x, and that should equal to 6x. So I'm just going to use a technique of plugging in values. It's going to make things go to 0, so I'm going to try x equals, let's see, what would make this thing go to 0? So f prime, where is f prime 0? F prime is 0 at 4, so I'm going to evaluate it at 4. All right, 4 times 2 is 8. 8 minus 5 is 3, so it gives me a 3/8. Plus b, f prime of 4, so f prime of 4 is 0. And then 6 times 4 is 24, which means that a is equal to 8. Okay, now, in order for me to make this equal to 0, I'm going to have to deal with fraction. I don't want to deal with fraction. I'm just going to pick another value, but I already know what a is. So I'm going to say 8, 2x minus 5 plus b f prime of x is equal to 6x. I'm just going to look for something pretty that I can just kind of plug in here that I'm going to get a good value. Let's see. It looks like on my drawing here that I can plug in 1 and I can get 6. So I'm going to plug in 1. So I'm going to let x equals to 1. So that would be 8 times, so 2 times 1 is 2, minus 5, so that's -3, plus b. F prime of 1 is 6. And then 6 times 1 is 6. So that gives me 8 times, that's negative 24 plus 6b is equal to 6, which means the 6b is equal to 30, which means that b is equal to 5. Okay, so now I know what a and b is, and I've taken up a lot of space here, so now I'm ready to go. I'm going to go ahead and see if I can fit it in here. So I'm going to rewrite this as the integral from 1 to 2 of a, which in their case is 8, over f prime of x, and then plus b, which I found it to be 5, over 2x minus 5 dx. Okay, so I'm looking at this thing, and now one more thing bothers me here. So this right here bothers me at the fact that I have that f prime. But once again, I think that ended up being such a key important fact. From 1 to 2, we are being told that from 1 to 6, f prime is a line segment. So we're going to figure out this line here, which actually this work that I scratched out earlier actually came out to help me. We found out earlier that that's what f prime is from 1 to 6. So from 1 to 2, it has to be the same. So I'm going to say 8 minus 2x. And at this point, this looks very simple in my opinion, okay? Because the integral of 8 minus 2x, the derivative, I'm sorry, that would be a negative 2. So I can put here a negative, which means I need a negative out here. And because I need a 2, I can leave this into a negative 2, and I can put a negative 4 out here. So I'm going to use that negative 4, and that doesn't change things. So that means that the integral of this, for this one at least, this part right here, that's going to be negative 4 natural log of 8 minus 2x. And that's going to be evaluated from 1 to 2. Plus, now I can integrate this one from 1 to 2. Well, the derivative of this is 2. So I can pull out the 5. I can put a 2 there, which means a 5 halves. So I got to have 5 halves ln 2x minus 5 evaluated from 1 to 2 once again. I'm running out of space again. Okay, so I'm going to plug in 2 here. So that's going to give us a negative 4 ln 8 minus 2 times 2 is 4. And then minus, because that's a minus, is going to be a plus 4 ln 8 minus 2. So in this case, we got, let's see, that's a 6. I'm sorry, that's a 4. So negative 4 ln 4 plus 4 ln 6. Okay, and now for this part over here, sorry, I'm getting all messy here. We got a 5 halves. So if I plug in 2, that's going to be 2 times 2 is 4. That's negative 1, but I have the absolute value, so that's ln of 1. Minus 5 halves ln, if I plug in 1, 1 times 2 is 2, minus 5 is negative 3. Once again, I got the absolute value, so it's 3. Okay, so now by the looks of it, I mean, I don't think I really need to clean this up, but I have a 5 halves ln of 1/3 on this side. And on this side, I can do a 4 ln of 6 over 4. So I'm just going to switch the order, so that's 2/3. So, sorry I'm running out of space. I just don't want to waste a whole lot of paper. So here's where I'm at. I have 4, I'm going to go this way, 4 ln of 3 halves plus 5 halves ln of 1/3. And I wouldn't really go any further than that. And to be honest with you, I think that should be pretty acceptable for them. Okay? Alright, so that should be part D, which leaves us with part E. Again, I think I've done pretty good timing on this. I kind of just pushed it to the limit, but I really want to make sure you guys understand everything by explanation. Which takes us to part E. And part E says you have a function k whose first derivative, so you're given k prime, is equal to f of x plus 2. You know that k of 1 is equal to 1. Find a third degree polynomial about x equals 1. Okay, so in order for me to get a third degree polynomial, I need 3 derivatives. So now I understand why they gave us that. Now you have k's of 1. I'm going to need to figure out the first derivative of 1, the second, and the third. So let me just find the derivatives first. So what is second? derivative of that. So it's a chain rule, so it's going to be f prime of x plus 2 times the derivative of the inside, which is just 1. And then the third derivative, because it's a third degree polynomial, so that would be the second derivative times, once again, it's just 1. So here's what it looks like. So I need to know what k of 1 is. So k of 1 is just 1. And then I need to know what k prime of 1 is, which in this case would be f of 3. And then I need to know what k double prime of 1 is, which in this case would be f prime of 3 as well. And then I need to know what k triple prime of 1 is, which in this case is going to be f double prime of 3. Alright, so a few of these things I think I can tackle real quick. So once again, so f prime of 3, all I got to do is look at this because it's f prime. So f prime of 3 is 2. So it's just 2. Now f double prime at 3, that means what is the slope at 3? Well, the slope at 3, if you remember, that was -2. So now what is f of 3? How do we figure out what f of 3 is? Okay, so f of 3, if you remember, was given to us. F of 3 was 7. So we don't have to do a whole lot there. And we're ready. I mean, as long as you remember your formula for Taylor polynomials, you should be good. So in this case, the third degree Taylor polynomial center at 1 is going to be 1 plus 7 x minus 1 to the first power over 1 factorial plus 2 x minus 2 to the second power over 2 factorial minus 2 x minus 1, sorry, that's a 1, to the third power over 3 factorial. You should be okay with leaving the answer like that. If you insist and you have time, you can simplify, and this is just going to be 1 plus 7x minus 1 plus x minus 1 squared minus x minus 1 to the third power over 3. Cool. So overall, not too bad. This FRQ made by Mr. Passwater really just hitting everything you need to know about all the strategies about integration. I think it's a great example. Hopefully this video helps you out to figure out whether or not you did the FRQ correctly from last week. Again, like always, if you have any questions, please shoot me an email and I'll be more than happy to answer them for you. We are almost there, guys. Keep working. I know it's been a tough year. I know with all the situations made it a little tougher, but this is our time to be resilient. And again, if you need any assistance, just let me know.